Hi, I'm Alex Kelly. Cutting to the heart of the question of how memory discriminates between things you've seen before and things you haven't are two classic memory experiments. In the fan effect, participants are slower to recall or reject pairs with a higher fan. A fan is how many times an item occurs in the studied list. For example, Hippie's store has a fan of 3 and 2. In the extra list feature effect, participants are faster to reject pairs with an unstudied item, regardless of the fan of the studied item in the pair. For example, even though Hippie has a fan of 3, it's easy to reject as a foil because school wasn't in the study set. These two experimental effects pose a challenge for existing computational memory models. Computational memory models allow us to formalize our theories of how human memory works. While there are many models, mathematical comparisons of the behavior of these models reveal strong similarities in approach across models. Simulating the fan effect using a few of these models, we find that while the ACT-R and HDM models can replicate the fan effect, Minerva does not. For recognition tasks, Minerva uses the dot product as a metric of similarity between a cue and the pair retrieved from memory. Using the dot product, Minerva correctly predicts that pairs with higher fans are more familiar to the participants. But the fan effect is not a familiarity judgment task. Discriminating between targets and foils requires correct recall. For recall tasks, Minerva standardly uses the vector cosine as a metric instead. The cosine is constant across fans, failing to predict increasing difficulty with higher fan. We note that the ACT-R and HDM models use 2 memory recalls, one for each item in the pair, and adopt the same strategy with Minerva. When we do so, Minerva is able to correctly predict the fan. A mathematical analysis of the models reveals that Minerva's failure to predict the fan effect is due to mutually reinforcing partial matches, which is eliminated by using 2 cues instead of 1. Other solutions may be possible, such as using 2 separate similarity comparisons for each item in the pair instead of 2 separate recalls. One intriguing possibility is raised by the RSS and IRM models, developed to account for another task that Minerva fails on, the ELF task. RSS and IRM propose contradiction as what's missing from Minerva. But the IRM's notion of contradiction is more accurately a sensitivity to the variance of the retrieved information from memory. We speculate that a memory model built on retrieving both the information content and the confidence in that information content may be better able to handle the fan effect and ELF effect tasks. Such a model could be implemented using a complex valued vector where magnitude represents the confidence in the information and the angle represents the information content. This proposed model is currently in development and the results are a matter of future work. Is there something fundamental missing from current memory theories, like confidence or contradiction, or is a change in memory recall strategy sufficient to well account for performance on these tasks? If the 2 recall theory is the correct one, we would expect to see participant responses in item pairs to be bimodally distributed based on the differing fan sizes of the 2 items in the pair. Testing this prediction would require further experimental work.